Hello everyone. In today's video, we are going to learn about function. In previous one, we have got knowledge about relation and its domain, range and codomain. Now, let's begin with the definition of function. Let A and B be two non-empty sets. A and B be two non-empty sets and a mapping or a function f. Let f be a mapping from A into the set B is defined to be a subset of A cross B, so that the following property must hold. That is, number one, for all A belongs to A, there exists some B. There exists some B belongs to B such that A comma B, that is the ordered pair of A and B, belongs to F, and number two, F will be single value. Okay, that is, if A comma B belongs to F and A comma C also belongs to F, that means B must be equal to C. Here the terms such as maps or mappings or correspondence are used basically as a synonym for function. That is, function or mapping are equal in sense. Okay, now here we see that there are two elements, small a and small b. Here small a belongs to A and small b belongs to B. So we can call A is a pre-image of B, and B also belongs to the set B. Now we call A is a pre-image of B under the function f, and we write it as B equals to f of A. Let us take an example. A equals to 1, 2, 3, 4 and B equals to A, B, C, D, E. Hence, are two non-empty sets. Suppose F1, F2, F3 and F4 be the rules which associate to each element of a set A into an element of B, as shown in the following figures, these four figures. Here we observe that in figure 1 and figure 2, F1 and F2 are functions from A into B, since each element of A is associated to a unique element in B under F1 and F2 both. Hence, they represent function. But in figure 3 and 4, minutely observe that F3 is not a function from A into B, since there is an element 3 belongs to A and which is not associated to any element in set B. Hence, F3 is not a function. It may be rules, but it's not a function. In figure 4 also, you can see that there is an element 4 which belongs to A is associated with two elements C and E of the set B. Hence, this also does not represent a function. Okay? Why this is not a function? Because in a function, if images are always unique, here if images means 4 has two images C and E both. Hence 4 here is not unique images. Codomain and range of a function. Let f be a function from A into the set B. Here A and B also two non-empty set. Here A is called domain of a function and B is called codomain of a function. Let A and B ordered pair A and B belongs to F for some A belongs to A and B belongs to B. Then B is called the image of A, image of A under the mapping or this function F or F images. Okay, now what is range? The set of all F images, the set of all F images of the elements in A is called the range of F, that is the collection of B's, the collection of B's are called range of F. Let us take an example to clarify this. F natural into natural set is given by fx equals to x minus 3 for all x belongs to natural. Clearly, this rule does not define a function from n, that is natural, to natural itself. Why? Because if you take 1 is also natural number. If you take 1, then f of 1 equals to 1 minus 3 equals to minus 2, and minus 2 does not belong to natural number. Hence, this rule does not define a function. Now, let us introduce the function as graph. What is graph? The curve obtained by plotting all the ordered pair x, y, all the ordered pair, this is called ordered pair x, y, corresponding to a given function f where y equals to fx is called the graph of a function y equals to fx. Now, properties of function reflects in graph. Number one, if every line drawn parallel to the y-axis, again I repeat, if every line drawn parallel to the y-axis cuts the graph at one and only one point, then the curve represents a function. That is, this is the Cartesian coordinate system x and y. This is x and this is y. If every line, any line, it may be curved line or parallel, a straight line, every line drawn parallel to y-axis, parallel to the y-axis cuts the graph. That is, you may have, this is the graph line, line parallel to y-axis, that is this, parallel to y-axis. This is also a parallel to y-axis. This is also a parallel to y-axis. Cuts the graph. This line cuts the graph at only one point. This line also cuts this graph in here, and this line also cuts the graph in only one point. There is no cutting another point. Hence, this is the function. This graph represents a function. Now, if you draw this curve, hence the line parallel to y-axis cuts this curved line in 2 points. Hence, this curve does not represent a function. If fx less than equal to gx for all x, then the graph of fx lies below always. The graph of fx, this is, you may take at fx graph, the graph of fx lies below the graph of gx. Then you may take this is a gx. Always. If fx less than equal to gx, then the graph of fx is always below the graph of gx. Now see, y equals to f of x plus a is the same as y equals to fx graph, but it's shifted a unit to the left because here is a sign is plus. Then the graph of y equals to f of x plus a is exactly same but shifted a unit to the left when a is positive and shifted to right of a unit if a is a negative sign. For example, let this is y equals to f of x. Y equals to f of x. Now, let this is y equals to x square graph. Y equals to fx here, fx equals to x square. Now, if we take y equals to x plus 2 whole square, that is y equals to f of x plus 2, then it's shifted to 2 unit left and the graph is just like this. And the third one is, if we take y equals to x minus 2 whole square, then This graph is just shifted to 2 units right. Okay, this is y equals to f of x plus 2. This is y equals to f of x minus 2, and this is y equals to f of x. Now see, y equals to fx plus a is the same as the graph y equals to fx also, but shifted a units upward when a is positive and shifted a units downward when a is a negative along y-axis. For example, let this is y equals to fx graph as y equals to x squared. Here is y-axis and this is x-axis. Now this is x and this is y. Now y equals to x squared plus 2 suppose. Then what is the graph of this function? The graph is like this. That is 2 unit upward. And if we take an example x squared minus 2, then the graph is like this. 2 units downward along y-axis. The previous one is along x-axis. That is, the graph is shifted along x-axis always. But here the graph is shifted along y-axis, that is up and down only.